Okay, so we're on to the C grade questions now then in this May 2015 paper 1. So an angle properties question here. You need to know that angles, straight lines that cross the opposite angles are the same. So if that is 56, that is 56 there. If that is 90, that is 90. And if that is x, that is x. So what we've got on this straight line is that 90 plus x plus 56 must add up to 180. So 146. So if we do 180 take away 146, that will give us x. So 4, that becomes a 7, 34. So x equals 34. Right, if ABCD is a rhombus, that means it's a squashed square. All the sides are the same length, which means that that makes an isosceles and that makes an isosceles, but also those triangles are the same. So if that's 126, that's 126 as well. So we do 126 from 180, and because it's isosceles, those two are the same, divided by 2 will give us y. So 180 take away 126, which is 54. So y would be 54 divided by 2, which is 27. Right, marks for that one. So you got a method mark there for making that add up to 180, one mark for 34 degrees. And for this one, you've got a method mark for recognizing that those triangles are the same, a method mark for taking them away from 180 and dividing by 2, and an answer mark for 27. Question 14. In a factory there are two machines. Machine A makes plastic spoons and machine B makes plastic forks. Both machines work at a steady rate, so that means that at any point they're working at the same, producing the same number of spoons or forks every time. Both machines start their production on a Monday morning at 9 AM. Both machines are stopped for maintenance after 450 spoons have been produced. Calculate the time at which the machines were stopped and the number of forks produced in that time. So spoons. So 1 hour, 180. So after 2 hours, there'd be 360 spoons. So after 3 hours, there'd be another 180 there. So if you add those together for another 180, you get 540 spoons. So it's stopped between 2 and 3 hours. We need another 90 spoons to make 400. And if it does 180 in 1 hour, in half an hour it would do 90. So for 450 spoons, it would take 2.5 hours. Two hours to do 360, and then you need another 90 to make the 450. So it's another 30 minutes, 2.5 hours. So the machines are stopped at 9 and 2.5 hours, 11:30. So the machines are stopped at 11:30, and the number of forks produced in 2.5 hours would be 240 plus 240 plus, in the half an hour, 120. So 600 forks. Okay, so that's quite a confusing little question, but actually when you actually sit down and start working through it, it's not too bad. Right, so marks for that one. When you're working the spoons, you've got a method mark for working progressively through it. You've got an answer mark for 2.5 hours and an answer mark for turning that into the time. Then you've got a method mark for working out 2.5 hours worth of forks and an answer mark for 600. Question 50. The map below shows a route from Edinburgh to Dundee. The route from Edinburgh to Dundee is approximately 4 centimetres on the map. The actual journey is approximately 100 kilometres. So we don't have to measure it because they're telling me there that 4 centimetres is 100 kilometres. So to get it into this ratio form, hopefully that phone will shut up in a minute, the first thing we need to do is turn the 4 centimetres into 1 centimetre by dividing by 4. So when we divide by 4, we get 1 centimetre is equivalent to 25 kilometres. So 1 centimetre on the map is equivalent to 25 kilometres in real life. Now to turn it into a ratio, I need to have this side of the scale in the same units as this side of the scale. So first of all, I know there are 1,000 meters in a kilometer, so I can write that as 1 centimeter is 25,000 meters. But that's still not something that I can put in a ratio form, because that is centimeters, that is meters. So in order to turn it into centimeters, I need to times it by another 100, because there are 100 centimeters in a meter. So 1 centimeter is 25 and another 2 zeros to turn it into centimeters. At that point I can remove the centimeters because both sides are in the same units and write it as a ratio. So we've got 5 zeros. So that's something that doesn't come up very often at all on a GCSE maths paper. Hopefully your memory from geography would help you with that. The journey from Edinburgh to Dundee takes 2 hours 30 minutes by car. Calculate the average speed of this journey. So speed, hopefully you can remember again, maybe from science, is distance over time. The distance is 100 kilometers. And where you have to be careful here is when you're writing 2 hours 30, you've got to write it as a decimal correctly. And 2.30 is the most common mistake. Remember, 30 minutes is half an hour. So it's actually 2.5. Now, 100 divided by 2.5, don't like the idea of that. But if I double both of those numbers, I get 200 divided by 5. As long as I double them both, there's nothing wrong with doing that. 5 into 20 goes 4 times, so it's 40. Both of those things do not come up very often at all on maths papers, but they're in the syllabus and they are something that, as you can tell, you could be tested on. So your method mark there is for getting it down to 1 centimeter equals 25 kilometers, and then the further mark is for dribbling it down turning it into meters, then centimeters, to write it like that. For part B, then we're looking for a method mark for distance over time and a method mark for the 2.5 rather than 2.3, and then 1 mark for correctly dividing. Right, question 16 again is unusual on a foundation tier paper. More often than not, parallel lines are a higher tier question, but in this straightforward form they crop up every so often. So the parallel line knowledge that you need here is that that 76 is in a Z angle with that. So that angle there is also 76. Then hopefully you can see that I've got an isosceles triangle here, and the angle at the bottom of the two equal sides are the same. So this angle is going to be 180 less 76 plus 76. So 76 plus 76 is 152. So that bit in there is going to be 180 less 152, which is 28. So that angle there is 28. So x is going to be 180 less 28, which we know from up there is going to be 152. So x is 152. Now, what I've just seen here is that it also then says you must give a reason for each step of your answer, which I haven't done. So let's start it again down here then. So angle C is this parallel line. Now the way you tend to remember it is it's called a Z angle, but that wouldn't get you the marks. Okay, so angle C ECB equals 76 degrees, and the reason is it's called an alternate angle. Then because of that, angle CEB is also 76. Angles at end of equal sides in isosceles are equal. So then EBC equals 28, which we've worked out here. Angles in triangle add up to 180. So angle X equals 152 angles on straight line. Add up to 180. Right, so there are 6 marks there. Before I started explaining or writing down why, you'd have got 4 marks. So there were 4 marks for that one being 76. Then there were 2 marks for getting the 28 degrees here, the method and the answer for getting those 28, and then an answer mark for the 152, and then the explanation stuff will get you the additional 2 marks. That would be the hardest one for you to get in the foundation tier, because you'd have probably called it a Z angle. The others are ones that we use quite a lot in the foundation tier. Okay, question 17. How many have we got to go? 3 more. Rotate A through 90 degrees anti-clockwise about the point 2, 1. So this is another rotation question. So it's another one where it's worth you getting your tracing paper out. Draw the shape that you want to rotate. Draw an arrow up the grid. So we want to rotate this about the point 2, minus 1. So it's across 2, down 1, which is there. 90 degrees is a quarter of a turn. Anti-clockwise is in that direction. So I want to turn this until that arrow is pointing that way. So you pivot where your center is and you keep turning until your arrow is pointing in that direction. So you can see there that it is going to go like that. So there's your rotation. Using the point B as the center, enlarge the quadrilateral by a scale factor of 2. So every point is going to be 2 away, or twice as far away from B as in the original. So that one is 1 down, so in the enlargement it will be 2 down. This corner is 1, 2, it's going to be 2, 4. This corner, and then you can work it out from there. Then that's 3, so this is going to be up 6. 1, 2, 3, 4, 5, 6, and then finally this corner is across 2, up 3, so it's going to be across 4, up 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So those are the points. Join them up. Try not to smudge. Use a pencil. So to get the 2 marks, that's the shape that you need to produce in that position. If you've made an enlargement anywhere else and the enlargement is correct but its position is wrong, you would get 1 out of the 2 marks. Okay, so for this one you'd have 1 mark for a rotation of 90 degrees anti-clockwise, both marks if you've pivoted it around the correct point. And as I said, with this one, 1 mark for correct enlargement anywhere, both marks if it's in the correct place, position as well. And then we're on to the last couple of questions. Question 18. The diagram below shows the part of a regular polygon. How many sides does this regular polygon have altogether? So you need to remember, the key thing is that the sum of the external angles add up to 360. So if you can work out one external angle and divide that into 360, it'll tell you how many sides you've got. So the first thing you need to do here is work out what that external angle is, which is going to be 180 less 162, which is 18 degrees. So the number of sides will be 360 divided by 18. So 18 into 3 doesn't go, 18 into 36 goes twice, so it's a 20-sided shape. So if angle properties of polygons were fresh in your mind, then that is something that would have been a straightforward question. 1 mark for the exterior angle, 1 mark for dividing that into 360, 1 mark for the answer. Question doesn't come up very often on a foundation tier. Similarly, this doesn't come up very often on a foundation tier. So this takes me back to the start really, where I said that this paper was quite challenging because at the end of it there were lots of unusual questions. So a hollow cylinder is made with an internal radius of 4 centimeters and has an internal height of 10 centimeters. Carwin says this cylinder holds approximately 5 litres of liquid. By estimating pi as 3, show whether Carwin is correct or not. So we want to work out the volume of that. The volume of that is the area of the circle, area of the cross section is a prism, times the height. So the area of the circle, you need to remember pi r squared. Well, pi, it's telling us to use as 3 because this is a non-calculator paper, and r squared is 4 times 4. So 12, 3 fours are 12, 12 fours are 48 square centimeters. So the volume is going to be 48 times the height, which is 10, 480 centimeters cubed. Now 5 litres, if you remember earlier on in the paper, 1 litre is 1000 cubic centimeters. So he's saying that the cylinder holds approximately 5000 cubic centimeters, and it doesn't. It actually holds only about half a litre. So just by saying it holds less than 1 litre would be enough. So it's only worth 3 marks, but it's 3 marks that not many foundation tier students are going to get. So you're going to have 1 mark for the method of finding the volume, 1 mark for 480 cubic centimeters, and an explanation mark comparing the volume you've calculated with the volume that Carwin seems to think it is. So pretty challenging, those last few questions.